Okay, so now we are doing question 5. Let's see and let's enjoy, okay? So question 5, question 6, question 7 of this tutorial 3 seem to be just asking about continuity and continuous stuff. Continuity is just one statement. It's you know what I mean? It's not that it's not even anything. So we should be able to do that. So let's see it as we go through this. One statement that we always test. Now it says determine whether the functions blah 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 and this one and this one and this one are continuous at x equal to -2. They will always ask. There'll be a controversial point. There'll be a point in which something may not. Remember, when we say it's continuous, we just mean we should be able to draw if it's a graph without lifting our hand, okay? But there may be something which may cause it, like you can have a hole or something. This is a discontinuity. But now we are an asymptote, where you have an asymptote where your graph does never touches that point. So you would have to jump it and continue on the other side, and that is a discontinuity. But we'll be just trying to see if this thing doesn't have those and it's just continuous from start to finish. And we always test with an equation. There's an equation that they develop for us, the mathematicians, which we always use. All we have to do is use. Imagine, we didn't have to develop it. So here, what is it? They're saying at x equal to 2. Okay, that's the point that is the controversial point. That is the point where some of these functions may not be continuous. That is where there may be a discontinuity, maybe an asymptote or a hole or whatever. So they want you to test and prove that there is nothing like that. Okay, so here we have f of x being equal to x to the power of 4 minus 16 all over 2 plus x. And they said check if there is if the function is continuous at x equal to -2. Okay, so we can now just write here to say for continuity at x equal to -2, we can do it. We can now say f of -2 should be equal to the limit as x approaches -2 of f of x. So this is what should happen. This is the equation. I mean, honestly, that's all you do. So you should find f of -2 and find this limit. And if they're the same, then you have continuity, okay? If one of them is or does not exist or gives you 0 over 0 or whatever, then that thing will not be continuous, okay? This thing you should be able to find an answer there. And this limit must exist. And they should be the same. So those are the three conditions. F of -2 should be there, limit should be there, and not only should they be there, if they're there and both are there, it's good, but they should also then be equal to each other. If they don't meet those three things, then it's a problem. So let's start with f of -2. So we are going to rewrite now to say f of x is going to be equal to x to the 4 minus 16 all over 2 plus x. Now we are going to put f of -2. This is going to be negative 2 to the 4 minus 16 all over 2 plus -2, okay? What is this going to be now? Remember, we are putting -2, so this just becomes -2 to the power of 4, blah, 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 blah. But we know that the bottom is going to be a 0, which is a big problem. And if we just, for courtesy's sake, we say -2 to the power of 4, you get 16, and it'll be 16 minus 16, which is going to be 0 over 0. And this is a major, major problem, okay? So this is undefined. You cannot have 0 over 0. This is undefined. So you can therefore say, we know that this was supposed to be there. We're supposed to get a solution for f of -2. We're supposed to get this limit, and then they were supposed to then be equal. But if it doesn't even exist, then there's no way we can continue with this continuity equation. So we can say, therefore, function is not continuous. Function is not continuous at x equal to -2. Okay? Or if you want, you can you can say, therefore, f of x equal to x to the 4 minus 16 all over 2 plus x is not continuous at x equal to -2. You can put that, okay? So this is going to be your solution. Or you can even to say therefore here in full to say, we can even say, you can even say therefore. So, whatever. You can do that and you still get your solution to say therefore I don't know why it's shifting to say therefore. Put it there. F of x, whatever, is not continuous. I mean, we've done it. This is what we have to do. We just check the continuity equation all the time. Whenever you see something about continuity, check the continuity equation. How simple it is. Now let's go and do B and C in the next video. Goodbye for now.